Welcome! In this module, we'll introduce the role of the Flexera 1 beacon and why its configuration is essential. The beacon acts as the secure communication hub between your endpoints and Flexera 1. It distributes machine policies, handles inventory and usage uploads, and ensures that your devices can reliably report hardware, software, and compliance-relevant data. The beacon is responsible for hosting all the configuration and policy information that Flexera inventory agents require. It receives hardware, software, and usage data uploads from agents, then forwards those files to Flexera 1. Because the beacon supports all agent platforms, Windows, macOS, Linux, and Unix variants, it forms the backbone of enterprise-wide visibility. The beacon is essentially the communication bridge between devices in your network and Flexera 1. When planning beacon deployment, consider capacity. Each beacon can support roughly 25,000 inventory agents. Large or distributed environments should deploy multiple beacons across network regions. Assigning subnets to each beacon helps ensure devices connect to their nearest beacon, reducing latency and improving data reliability. To ensure reliable communication between Flexera inventory agents and the beacon infrastructure, several key network requirements must be in place. First, each agent must be able to reach its assigned beacon over port 443, which is the preferred and secure HTTPS communication channel. As an alternative, port 80 may also be used when HTTPS is not enabled. This is essential because agents upload inventory and download policy through these ports as part of routine operations. Next, firewalls must allow outbound connectivity from the agent machines to the Flexera beacons. Without this outbound access, policy downloads, inventory uploads, and certificate validation checks cannot occur successfully. It's equally important that DNS resolution for the beacon's fully qualified domain name, FQDN, succeeds. DNS misconfiguration or failure will prevent the agent from locating the beacon, which stops all communication. Both Windows and non-Windows troubleshooting procedures specifically validate DNS resolution as a required step. For environments using HTTPS, certificates used by the beacon must be trusted by the agents. This includes ensuring that certificate authorities, CRLs, and any required intermediate certificates are reachable and validated. Non-Windows agents require trusted PEM format certificates during installation, and certificate validation is a common checkpoint for troubleshooting communication issues. Finally, network segmentation should be designed so agents communicate only with their designated beacons. This ensures proper load distribution, since each beacon supports a defined number of agents and supports security policies that restrict cross-segment communication. Flexera guidance highlights that communication restrictions may prevent agents from reaching beacons unless segmentation is configured intentionally. These requirements together provide the foundation for stable, secure, and predictable communication between Flexera agents and beacon servers. Additionally, all Flexera beacon servers should be sized based on the guidance provided on the current slide in each environment. As far as certificate requirements go, beacons using HTTPS must provide certificates with correct FQDN and SAN entries. Windows agents rely on the OS Trust Store, but non-Windows agents need a bundled PEM file containing all certificates, named MGSFT Rollout Cert. Download the certificates from the beacon/manage softrl test endpoint. If certificate validation fails, verify CRL or OCSP accessibility and temporarily disable revocation checks for troubleshooting. Now that we've gone over some of the requirements, let's go over the installation of the beacon. To install a Flexera beacon, begin by downloading the installer from Flexera 1 under Data Collection Installers. Next, retrieve the required beacon certificates directly from each beacon's HTTPS URL, saving them in PEM format for inclusion, especially important for non-Windows environments. Then, place the installer and supporting files on the target system. Finally, run the installation using administrator or root privileges to complete the setup and enable secure beacon communication. After installing the beacon, start by testing the beacon URL using curl or PowerShell. A successful response should return the word success. Next, verify DNS resolution by running NSLOOKUP on the beacon's fully qualified domain name and confirming it resolves to the correct IP address. Then, ping the beacon to confirm basic network reachability. Any timeouts may indicate connectivity issues. Follow this by checking port connectivity, preferably on port 443, using testnet connection on Windows or netcat on non-Windows systems to ensure secure communication is available. If any test fails, review firewall or proxy configurations to confirm required ports are not being blocked. Now that we've gone over the requirements, let's summarize it all with some best practices surrounding the beacon. When deploying beacons, start by sizing and segmenting them appropriately. Each beacon can support roughly 25,000 agents, so align beacon placement with your network segmentation to ensure agents reach the correct beacon. Next, assign subnets to each beacon. This helps balance communication loads and ensures agents connect to the appropriate regional or segmented beacon. Always use HTTPS over port 443 for beacon communication, as it provides secure encrypted traffic. Avoid HTTP on port 80 whenever possible since it is not secure. Ensure beacon certificates are configured correctly, including the full FQDN and any required aliases, so agents can validate the HTTPS connection without errors. Finally, routinely validate DNS and network connectivity to ensure agents can reliably resolve and reach the beacon across your environment. The beacon is foundational to Flexera's inventory infrastructure. Reliable DNS, open network paths, and correct certificate management ensure consistent communication. Regular validation and log review help maintain long-term stability.